Hey everyone, happy Wednesday. So today's work is an um, elements on the periodic table review as well as the Bohr model review. So this is stuff that you learn in sixth grade. So we are going to spend all of today reviewing, and then tomorrow we'll get into some newer stuff. But we want to make sure we have a good, solid base understanding of this stuff before moving forward. So with elements on the periodic table, there are a few things that we need to be able to identify. So the first one is the atomic number, which is always going to be the smaller of the two numbers that you see. So in this case, aluminum has an atomic number of 13, which means that aluminum is the 13th element on the periodic table. So I'm going to go ahead and type 13. All right, the mass number is the total number of protons and neutrons in the nucleus. So that's why it's the bigger number, because it's also the neutrons involved. So the mass number in this case is going to be 27. If you can remember from last year, the atomic number is always the same number as the protons. All right, and then I'm going to jump down to neutrons. So just a reminder, protons are positively charged. You can think of it like P proton, P positive. Electrons are negatively charged, and neutrons are neutral charged, so they have no charge at all. I don't know why I'm glitching a lot. Okay, so protons are always the same as the atomic number. Neutrons are going to be whatever is left. So what we're going to do is we're going to take this atomic mass number, which is 27, because that's the total of protons and neutrons, and we're going to subtract the number of protons or the atomic number. Both are the same thing. All right, when you do that, you should get 27 minus 13, which is going to give us the number of neutrons, which is 14. Okay. Now, going back up to electrons. So electrons, I skipped this because there are a few things I want to touch base on. So there are some elements that are negatively charged, there are some that are positively charged, and then there are some that are all just neutrally charged. So in this case, we're going to assume that all of these examples you guys are going to go through are just neutrally charged atoms or elements, because we're going to get into ions and isotopes and all that stuff later on, which means that an element is negative or positive. And you guys did some of that in your reading and learned some about that then. But today, we're just going to assume that every single element is neutrally charged. So if an element is neutrally charged, that means that if the protons are 13, the electrons are going to be 13. And just to kind of go over why that makes sense. So if we have 13 protons, that means we have 13 positively charged parts. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And think about it like math. You guys are learning or have learned positive and negative numbers. And remember, if you add a positive and negative number together that are the same number, they're going to cancel each other out. So if, let's say, this positively charged proton is like a positive 2, well, what's going to cancel out a positive 2? A negative 2. So that's why that for every proton that's positively charged in a neutral atom or neutrally charged atom, we're going to have one negatively charged electron. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, well, they don't line up, but assume that they do, because each one cancels each other out. All right, so that is just how to read the periodic table and read an element. So for each of the 4 examples, I would like you to finish those up. All right, and then today you're going to be also reviewing Bohr models. So this was something talked about in 6th grade as well. So with a Bohr model, you want to make sure that you understand how to identify protons, how to identify neutrons, and then where your electrons really go. So if we're looking at oxygen, oxygen has an atomic number of 8, and the atomic number is always the same as the number of protons. So our atomic number, or our protons, are 8. So we have 8 protons in the nucleus. And then to find the number of neutrons, we would just do the atomic mass minus the protons, which would be 8 as well. So 16 minus 8. So just to recap on a Bohr model, this is what a Bohr model looks like. So this inside this green little circle, that is considered the nucleus. So you guys have definitely seen pictures or cartoons of atoms. You have like a dense nucleus, and then you have electrons like flying around in these things called energy fields. So that's exactly what we have. So our nucleus contains our protons and neutrons, and then surrounding it, we need to be able to place our electrons correctly. So with Bohr models, there are 3 energy fields. So we have the first one, the second one, and then the third energy field. So the more energy fields, the more electrons an element or an atom has, the more charged it is, because it has more electrons flying around. So the rules with the Bohr model is that the first energy level can only hold 2 electrons. So what I'm looking for here is that you are clicking and dragging the appropriate number of electrons. All right, so first energy field is going to only capable of holding 2 electrons. But then the second and the third are capable of holding 8. So we need to be careful on how we place them, because that's just how the Bohr model works. We have to place them in certain areas around the energy fields. So oxygen, since it's neutrally charged and the protons are 8, that means the electrons are 8. So we have 1, 2 in the first field, and then we're going to see if we can fit 8 in the next field. All right, so how we're going to lay this out is we are going to kind of put them in pairs. So I'm going to put 1 there and 1 here, 1 here, and 1 here, 1 here, and 1 here. So if it doesn't totally fill up the energy field, that's totally okay, because that's just how oxygen is. Oxygen has 8 electrons, so that's how many it's going to be holding in these electron fields. All right, so for this, then you are going to be doing that exact same thing for each of the Bohr model practices. So that's your asynchronous work. And then tomorrow in the beginning of class, we're going to go through this whole worksheet, and then we're going to just continue on learning about more chemistry stuff. All right, have a great day, everyone, and I will see you tomorrow.